So we're going to look at percentage increase and percentage decrease problems. So let's take a look at this first one. You buy a shirt for $35. If sales tax is 6%, how much is the sales tax and how much do you pay altogether? So you probably understand how to do sales tax, but let's go through it. Anytime we have a sales tax of a percentage, we take the amount that we're paying and multiply it times that percentage listed as a decimal, which would be 0.06 in this instance. So $35 times 0.06 gives us $2.10. Now that's the amount of the sales tax. We have to take that sales tax and add it to the original $35, which gives us $37.10 that we will pay. All right, now there is a shortcut here if we're just looking for how much we pay altogether. I want you to notice that this 35 right here is really 100% of 35, and 100% as a decimal is 1, right? And then our 210 is really 35 times 0.06. So it turns out that there is a shortcut, and that's to take the $35 and multiply it by 1.06. Notice this 1 plus this 0.06. And this will give us the $37.10. Now, in this case, we really had to do two steps because we had to find out what our sales tax was first. But if we're only looking for the final amount that we have to pay after the sales tax, we can use this shortcut. So let's notice what this shortcut is. It's the original amount, that was our $35, and then 1 times 1 plus the whatever the percentage is as a decimal. So in the case of our percentage, it was the 6% or 0.06. And I'm sorry, the dog is making noise in the background. Now you might notice that this looked a lot like, a little bit like the exponential growth that we saw earlier. And we will note later on that in some ways it is very much like the exponential growth when we're talking about percentages. So this leads us to an overall formula for percentage increases. The total amount after an increase is equal to the original amount times 1 plus whatever our percentage is as a decimal. That's anytime we have an increase. Now, let's take a look at this second example where we're going to do a decrease in our price because we've got a discount. So you find a shirt for $35, but it's on sale for 20% off. How much is the new sales price of the shirt? Now we'll start by doing it in two steps, but then we'll see that there really is a shortcut again. So let's take our $35 and multiply it by 20% as a decimal. That's going to tell us how much we get off. All right, so 35 times 20%. That's really a $7 discount. All right, so really, what's the new sales price on the shirt? Well, we've got to take the $35 that was the original price and subtract off the $7 that we're going to get off, and we're going to pay $28 for this shirt. Now, of course, there'll be taxes later, but that's not what the question asked. Now, we did this in two steps, all right? But let's try to pull this together into a one-step problem. So let's notice that we really took our original $35 and we subtracted off 35 times 20%, all right? And really our 35 that we subtracted it from was 100% or 1 as a decimal of the original price, all right? So really this amounts to 35 times 1 minus 0.20. Okay, so let's get us a general formula from that. All right, so it's original amount times 1 minus the percentage as a decimal. Or if we want to make an overall formula that works for all percentage decrease problems, so this is going to be total amount after a decrease is equal to the original amount times 1 minus percentage as a decimal. All right. Now, sometimes we're going to have to go through our first step in all of these. For example, if it asks us how much we're going to get off, we're going to have to do this original multiplication to find out what those $7 are that we're going to be getting discounted off. All right. But if we're just asking for the final price, we can go straight to this formula. Just as with the sales tax, if it's just asking for the final price after the sales tax is added, we can go straight to this formula. So let's look at one last problem. After a 30% discount, a dress sells for $25. What was its original price? Now let's notice it's a discount, so it's a decrease in price that we're talking about here. So we want to use this formula that I used right up here since we're talking about a decrease. Now we already have the total amount after decrease. It's $25. So let's put that on the left side of the equation because we're going to solve an equation. We'll have 25 equals. The original amount is what we don't know. So let's just call it X. And then 1 minus our percentage as a decimal. Our discount was 30%. Change that into a decimal. It's 0.30. So we've got 25 equals X times 0.70. And then let's just use our normal solving of an equation. We've got 0.70 times X to get rid of something being multiplied by X. Let's divide it out. So we'll divide by 0.70 on both sides. And then on the right side, I'll just get my X. On the left side, though, I need to put 25 divided by 0.70 into my calculator. And I get, and I'll round it off to cents because we can assume that we are dealing with just money here and we don't have to go beyond 2 decimal places. So it's $35.71. And of course, we want to make sure that our original price was bigger than what we paid after the discount. And of course, it is.